Hi everyone. So we're at our first meeting for Math 126, first live meeting. We've got a good group of people here. New technology, used it this morning a little bit more before this meeting, and I'm going to see if we can record it. They don't offer a way to record it yet, so I'm recording it with this program on my computer, then we'll put it on YouTube, which is a little more work for me to render it and all that, but it's fine. So the question someone had earlier had sent me an email about it. They're asking that they're reading something on page 33, and I commend people for reading the book. Yay, read the book. It was really from the Conjugate radical expressions, rationalizing denominators. So if you have like 1 over the square root of a plus the square root of b, you would multiply that by the square root of a minus the square root of b over the square root of a minus the square root of b. And the numerator becomes square root of a minus the square root of b, but the denominator, you end up with square root of a times square root of a. So that's square root of a squared. Square root of a times negative square root of b, so negative square root of ab. Square root of b times square root of a, so positive square root of ab. Square root of b times negative square root of b, so negative square root of b squared. So the numerator is still, square root of a minus the square root of b, and the denominator, notice it's negative square root of ab plus square root of ab, so those are going to subtract out. And we end up with the square root of a squared, which is going to be a, minus square root of b squared, which is b. So this is square root of a minus square root of b over a minus b, because the square root of a squared is a. Square root of b squared is b. No, not a squared again, Jeff. Come on. So that's what we end up with. And that's called rationalizing the denominator. So if you have the sum or difference of two radicals in the denominator, this is how you deal with that. For example, or one other side note, if this was a difference here, we would multiply by square root of a plus square root of b over square root of a plus square root of b. And again, this is just 1. Something over itself is just 1. Now, the question then came up, if you look at example C, or part C, example 9, C, they have negative square root of 5x over 5 minus the square root of x. And what do? They multiply by the conjugate of this denominator, which is going to be this, or 5 plus the square root of x. Erase, please. 5 plus the square root of x over 5 plus the square root of x. So our numerator becomes the negative of square root of 5x times 5 is negative 5 square root of 5x. And then negative square root of 5x times square root of x is negative square root of 5x squared. And down below we have 5 times 5 is 25. 5 times square root of x is plus 5 root x. Negative square root of x times 5 is negative 5 root x. Negative square root of x times square root of x is negative square root of x squared. And so just as we saw earlier, this 5 root x and negative 5 root x, they just cancel out. And then we have in the numerator negative 5 square root of 5x minus, now we have square root of 5x squared. The square root of x squared is just x, so x comes out, and then we have the square root of 5. Down below we have 25 minus, and the square root of x squared is just x. So the reason that this is negative is because it was negative here, because we had a negative square root of x times a positive square root of x, and that's why it comes out that way. Now, you could argue, by the way, to be exactly correct, we're assuming in this that x is positive, otherwise you have to put an absolute value around the x, because that's how it works out, that the square root of x squared is absolute value of x. Unless x is said to be positive, then we don't have to worry about it. But they're not getting that technical in this book, and that's okay. So that was the one thing I really wanted to address for my student who emailed me. What else do we want to see today? Okay, so for 33 it says a cubed plus ab minus a squared b minus b squared. It says to factor by grouping. So let's try the first grouping arrangement that comes to mind is just leave it as it is. A cubed plus ab, I'm going to group those together, minus a squared b plus b squared. You're going to say, what happened to that negative? Well, I factor that out with these grouping symbols. It changes the negative to a positive, so it changed that sign. And then from this first pair, what do they have in common? Well, I could pull an a out. And from that second pair, what do they have in common? All I can see is I can pull a b out. So I have a times a squared plus b minus b times a squared plus b. And this a squared plus b is a repeated factor. So that becomes a squared plus b times what? Well, if those are both pulled out, what's left is an a minus b. Now the answer in the book, that's the same order as the answer in the book. I mean, multiplication is commutative, so you could change the order here. You could say a minus b times a squared plus b. That would be an acceptable answer as well. Let's see, how about maybe number 45? X squared minus 2x plus 1. Okay, the one technique I was trying to show in my lesson video is this diamond technique, and it's a diamond because it was originally like a diamond around this, but you put the constant in the top, you put the coefficient to the linear term, to the x in this case, down to the bottom. What two numbers add to be negative 2 and multiply to be positive 1? Well, negative 1 and negative 1. So this factors to be x minus 1 times x minus 1. So it's a minus 1 there, minus 1 there. And there it is factored. You could also write this as x minus 1 squared. Now I want to look at 49 as well. So 49 says it has 6x squared plus 5x minus 6. So we want to factor this one. I gotta get myself some more room to work here. Okay. Uh-oh. Uh-oh. I'm not able to view what I'm doing here anymore. Oh, there it is. Yeah, it's okay. I wanted to make sure it's still coming up okay. So let me know if this is not coming through. So this is what I call the AC technique. Excuse me, I hope I muted that in time. I had a sneeze there. So we have 6, our A is 6, the leading coefficient's A, the constant is called C, that's also 6. So A times C is 6 times 6, which is 36. So we're going to look for factors of 36 that add to be 5. And, oh, sorry, that's a negative 6, so this is a negative 36. So factors of negative 36 that add to be 5. And you can go through and start listing them like, okay, it could be negative 1 and 36, negative 2 and 18, negative 3 and 12, negative 4 and 9, negative 6 and 6. And right there, that's the pair. Negative 4 plus 9 is positive 5. So that this becomes 6x squared minus 4x plus 9x minus 6. So see how we replaced 5x with negative 4x plus 9x. So it's 6x squared minus 4x plus 9x minus 6. You may think I'm going crazy and writing things twice, but I like to write it a second time just so I can start grouping it. Out of the first pair, I can pull out a 2x. Then we'd have 3x minus 2. Out of the second pair, I'll pull out a 3. And we have 3x minus 2. So it's going to be 3x minus 2 times 2x plus 3. And that's factoring by grouping. Any questions there so far? Okay. I'd like to do one more if you guys will let me. Number 57. And I think it's from your homework. So it's 7a to the negative 1 minus 2 minus 2a to the negative 3 times b. One way to view this is, okay, this is 7 over a minus 2b over a cubed. If you can factor out what's the bigger power down below, that's a cubed. You're going to pull that out. So that becomes 1 over a cubed times. Now, if I'm pulling an a cubed out of here, what's the result going to be? I'm trying to think of the best way to express this. How about this? Let me back up. It might be easier to see it this way. I think this is a problem that gets most students. So 7a times a cubed over a cubed yeah, I could do that. Minus 2b over a cubed times a cubed over a cubed. So really I'm multiplying by 1 in each case. What does this have the effect of? Well, I can factor out this a cubed. So I'd have 1 over a cubed times 7 over a times a cubed minus 2b over a cubed times the a cubed. So that a cubed in the numerator stayed. I factored out the 1 in the denominator. And we'd have 1 over a cubed times a cubed divided by a is just a squared. So 7a squared. And then a cubed divided by a cubed is 1. So we just have minus 2b. And that's how that factors.